Problem 1, comparing mean and median. So compute the mean and median. So for the mean, we have to add up 1, 2, 3, 4, 8 of these values and divide them by how many there are, which is 8, which makes the mean equal to 224,500 for the mean. Yet again, that's just adding up all these values and dividing by 8. Okay. For the median considers the middle values. Min, max, min, max, min, max. Cancel out these numbers. Since it's even, you're going to be left with 2 in the middle, which you will add and divide by 2 to get the median, which is 147,500. State which measure better represents the typical house price. This would be the median, since there is a 800,000 outlier. So explain why the outlier affects. The outlier affects my answer because the mean is more influenced by this outlier, whereas the median only considers the middle values. The middle values, which make the median the better representative of our numbers. Problem 2, 5-number summary, box plot, and outliers. For the 5-number summary, start by finding the min, which is the lowest value, 55. The max, the highest value, 95. Finding the median, which if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If there's an odd number, that means there's only going to be one number in the middle. Since it's 11, we'll be right in the middle at 6, which will make our median 70. Our Q1, since there's an odd number of variables, you will not include the median. So you go high, low, low, high, and you have one left, which will be our Q1. Do the same thing on the other side to find our Q3. So our min is 55, our Q1 62, our median 70, our Q3 is 80, and our max is 95. So to find IQR, this is Q3 minus Q1, which equals 18. To find our lower bounds for suspected outliers, we have to do Q1 minus 1.5 times IQR. If we plug our numbers in, this equals 35. Now we do the same thing for our upper bounds, but instead with Q3, which is the right side of our box plot. So do the same thing, minus 1.5 times IQR for our upper bound, and this equals 107. So we're looking for an outlier. We have to look for a number below 35 and above 107, which we do not have on our graph, so there's no suspected outliers. For a box plot, take our 5-number summary, our min at 55, our Q1 at 62, our median at 70, our Q3 at 80, and our max at 95. Connect these, draw it correctly. Okay, so describe the skew and symmetry. So looking at this, the mean is much closer to Q1 than it is to Q3. Because it's closer to Q1, this would mean that the graph is skewed right. According to our data. Problem 3, the 68, 95, 99.7 rule. So because these are normally distributed, we can make a normal distribution curve. Something like this. So our mean is 12. The mean is right down the middle at 12 with a standard deviation of 2. That means to the right, add 2, 14. To the right again, add 2, 16. To the left, subtract 2, and we'll go 2 standard deviation, and we'll go 3. And this is 6 over here. Okay. So what proportion of packages weigh between 10 and 14? So because we went 1 standard deviation away from the mean would be 68. So this would be 68% of the packages weigh between 10 and 14 pounds. So number 1 done. Number 2, what proportion weighs more than 16 pounds? So this would be all of this. We are trying to find this sliver right in here. So this would be 1, 2 standard deviations away from the mean. So with it being 2 standard deviations away from the mean, this would mean that 95% is covered. But because we're not looking at the other side, divide that 5% that we're looking for in half, and you get 2.5% for the proportion that weighs more than 16 pounds. Problem 4, finding a value given a proportion. Assume SAT and math scores are normal with a mean of 500 and a standard deviation of 100. Find the score that marks the top 10%, so the 90th percentile of students. So we have to find the C score of 0.90. If you look at the chart, this comes out to about 1.282. So using the formula, x equals mu or something like that. See, plug in our numbers. X equals 500 plus 1.282 times 100 which equals 500 plus 128.2, which equals 628.2. So this would be the top 10% of students. So the bottom 25%. So we're looking for the 25th percent of students. So we need to find the z-score of 0.25. If you look at the chart, it says that it is negative 0.674. Using the same formula, x equals, I think it's mu, plus 7 plus c, sigma, something like that. Plug in our numbers, x equals 500 plus negative 0.674 times 100. Put that into a calculator, and it is 432.6 would be the bottom 25% of students, which is not a very good test score.